Hello everyone, my name is Susana Borbón and I am the presenter of the work titled ZnTiO3-based dye-sensitized solar cells. Best sensitization time on N719 dye by Shadai Lugo, Nayely Pineda, Israel López, and myself. As it is well known, to supply the current and ever-growing energy demand while diminishing the carbon emissions, we must migrate to the use of renewable energies, such as solar energy. Amongst the myriad of technologies to produce electric energy from solar energy, we can find the dye-sensitized solar cells. Since their invention in 1991, a variety of materials such as titanium dioxide and zinc oxide have been tested as photoanodes in DSSC. Owing to its electronic properties and chemical stability, compelling nanocrystalline structures in the system, titanium dioxide, zinc oxide have gained great interest for its use as photoanode materials in the DSSC. In this work, we synthesize zinc titanate nanostructures by cell-health method without using expensive inert atmospheres, templates, or surfactants. Moreover, we characterize the crystalline structure, electronic properties, and morphology for this material, and study the best sensitization time of zinc titanate photoanodes in N719 dye. For the salt-health synthesis of the material, we mix tetrabutyl titanate with acetic acid to control the hydrolysis of the titanium precursor. After 5 minutes, we added hydrochloric acid as a catalyzer. 1 hour later, we added zinc nitrate crystals to our salt, which was mixed and heated until the formation of the gel. The gel was thermally treated at 600 and 700 Celsius degrees for 2 hours. To produce the photoanodes, we prepared a paste of our material using terpineol, ethanol, and ethyl cellulose. This paste was deposited in the substrates by a screen printing technique to ensure a homogeneous deposition. Thereafter, the photoanodes were thermally treated at 530 Celsius degrees for 1 hour to eliminate the organic compounds. The photoanodes were immersed in an ethanolic solution of N719 dye for 3, 6, 12, 24, and 30 hours. The XRD patterns of our material synthesized at 600 and 700 Celsius degrees perfectly agree with the GCPDS card corresponding to zinc titanate in hexagonal phase. Hence, we selected the material thermally treated at 600 Celsius degrees to save energy cost. The estimated crystalline size of the sample ZT600 is 38 nanometers. On the other hand, the Raman spectrum further confirms the crystalline structure of the material, since all the signals can be ascribed to hexagonal zinc titanate. The morphological analysis exhibits the formation of nanocrystals with an average size of 39 nanometers, agrees with the calculated crystalline size. Therefore, a monocrystalline structure can be presumed. The optoelectronic properties of our material have been characterized by diffuse reflectance spectroscopy, and the bandgap energy has been calculated to the Kubelka-Monk transform, obtaining a bandgap energy of 3.6 electron volt. Since the material exhibited the adequate properties for its use as photoanode material, we conducted a study to evaluate the best sensitization time on the most commonly used and efficient DSSC dye, N719. Our study demonstrates that the material has reached its maximum dye loading at 24 hours and a dye absorption of 9.35 10 times to the minus 5 mole per centimeter. In conclusion, we have synthesized monocrystalline nanostructures of zinc titanate with suitable optoelectronic properties for its application as photoanode in the DSSC. In addition, we have demonstrated that the optimal sensitization time for N719 dye is 24 hours, endowing a dye loading in the order of 10 to the minus 5 mole per centimeter. And finally, thank you very much for your interest in our research work.